In this module, we will explain the fundamental concepts of importing external designs into GeneXus. This content is designed to be relevant for all the roles involved in this process. Let's start with this question. What design solutions does it offer us? GeneXus allows you to generate automated and sustainable design solutions that are essential for application development. These solutions can be implemented through 3 strategies. Use design systems that we have incorporated into GeneXus, such as the Unanimo design system. Adopt design systems provided by community partners, or implement custom designs developed externally. In this course, we will focus on addressing the specifics of this last strategy. Now let's move on to understanding what this tool is and how we can achieve a successful import. The Design Import tool allows design files created in programs such as Figma or Sketch to be automatically integrated into GeneXus. It accelerates front-end development and facilitates collaboration between design and development teams. In this course, we will focus exclusively on using Figma. It's essential to understand that in order to achieve a successful import, the design file must follow certain conventions, best practices, and specific adjustments, which we will explore later on. Let's move on to identifying where this tool is located in GeneXus and what we can configure in the import dialog. You'll find this tool by navigating from the toolbar to the Tools option and selecting Design Import. Here we can configure the import parameters, such as the file to be imported, for example. In the case of Figma, we need to provide the file's URL as well as an access token. You'll also find a checkbox to specify whether you want to import for web, mobile, or Angular. Once GeneXus analyzes the file, it will show you a preview of the objects that will be generated. This is a crucial opportunity to review controls, event codes, images, and styles before finalizing the import. The roles involved in the import process are as follows. On one hand, there's the designer, who is responsible for visually creating the product and proposing the user experience. Designers need to consider how their decisions will impact the import process and the interpretation of elements in GeneXus. On the other hand, there's the integrator role, which can be performed by a designer experienced in these specific adjustments or by a developer, a GeneXus expert with design knowledge, and they will be responsible for making the necessary adjustments to the file to ensure that GeneXus can correctly interpret all the elements. And finally, the developer. After the designer has created the file and the integrator has made the specific adjustments, the developer is the one who will import the design into GeneXus and must also make sure that everything is displayed and works as expected. Communication between these areas is essential to define key aspects that make it easier to maintain the knowledge base, such as naming layers, components, and styles. Now let's move on to how these design decisions impact GeneXus, and we'll look at it through some simple examples. Every element we include in the design has its equivalent in GeneXus, and it's important to understand this connection and relationship. The first step in our design process will be to define a frame to later draw the screens. This element is fundamental and is translated in GeneXus as the main table, either of a web panel object if we click the web option when importing, or a panel object for mobile and Angular cases. As we progress in our design, we will be adding various elements in the construction of our screens, and all of them will have a correlation with GeneXus objects. This correlation is not always one-to-one. That is, a Figma element has its equivalent in a GeneXus element. There are also scenarios where a Figma element can mean multiple elements in GeneXus and vice versa. Let's look at it using the example of text layers. In Figma, we only have one tool to place text. However, in GeneXus, there are several controls. These depend on the specific function of that text. Therefore, it's essential to clearly indicate what type of text we want to use to ensure correct interpretation. Visually, a piece of text can represent different things or intentions that, even if they look the same, serve different purposes. From this diversity arises the need to disambiguate elements that visually seem obvious but are not in terms of how GeneXus will interpret them. This case, for example, gives us that diversity. A piece of text can be a variable, it can be an input, it can be static text, or it can be the caption of a button, among other things. And the way to distinguish each of these texts so that the text layer in Figma is interpreted correctly on the GeneXus side is by using conventions. These conventions will be defined through prefixes placed on the layer in the design file. In the case of Figma text layers, GeneXus will interpret them by default as a read-only variable of type string. But if the text is representing a field where users need to enter data, it can't be a read-only variable. In that case, the integrator must use a convention to disambiguate this scenario and indicate to GeneXus that this text layer is an editable variable. The convention used is input, and as we mentioned before, it's added as a prefix to the text layer. In this way, by applying the appropriate convention, GeneXus will interpret the text layer as a read and write variable. In the case of static texts, meaning texts that we already know won't change throughout the application, the integrator must use the static convention. This way, GeneXus will interpret it as a text block. At this point, it's important to make a clarification and understand the difference between a text block and a text variable. Variables are dynamic text that can be sourced from either a database or an external service, while text blocks are static and are configured beforehand. Finally, let's take a look at the case of the button. If we place a frame with rounded borders and text inside it in Figma, we can easily recognize it as a button. But as we've already seen, these two elements are translated by default in GeneXus as a table and a text variable. For these two elements that we placed in Figma to be recognized by GeneXus as a button, the integrator needs to apply the convention button as a prefix in the layer name. This convention allows GeneXus to place a button control using the properties of the frame to define the shape of the button, while the text layer specifies the caption of that button. By understanding how these elements are translated in GeneXus, we can ensure that our designs are implemented correctly. These are just a few examples, and we'll see more throughout the course. Our intention is for you to remember that there is a connection between the layers of design and the elements of GeneXus, and that understanding this relationship is vital for the tool to work as expected. All these connections between design and GeneXus are documented in our wiki. To wrap up this module, we could say that the Design Import tool is an accelerator for front-end development in GeneXus, allowing design and development teams to work more efficiently and reducing the time needed to take a design to implementation. By making design integration easier, errors are minimized and the quality of the final product is improved. As we move forward in the course, we will dive deeper into each of these topics and explore how to optimize the import process in GeneXus. Up to this point, we've seen a general introduction to the Design Import tool. If you're a designer and you want to know the general considerations for creating designs to import, we recommend watching Module 2. If you are an integrator and already have a design, we recommend checking out Module 3 to learn about the necessary validations and modifications before importing it into GeneXus. And if you are a developer and want to learn in depth how to interpret a file in GeneXus, we recommend moving on to Module 8.